Okay, all of you. I was previously told about that FEM is a powerful tool for solving numerical solution for many engineering problems. History of FEM. The FEM is originated from advanced in aircraft structural analysis. They are said about that FEM is first initially developed for analysis of aircraft structures. For after, FEM is used for all numerical solutions for many engineering problems. It was named by Clough in 1960s. This is used for all numerical solution for many engineering problems. This is the history of FEM. Next. Here I am showing two figures. Those are for two-dimensional finite element discretization. It will be triangular or quadrilateral. Discretization means dividing. I will tell you later. For two-dimensional finite element discretization will be triangular or quadrilateral. For three-dimensional, it will be hexahedron or tetrahedron. I am showing first figure. Hexahedron. Hexa means 6 faces. Hexahedron means 6 faces. We already know about that. Hexa means 6 faces. Hexahedron 6 faces. Example for hexahedron is cube. Next, tetrahedron. Second one is the tetrahedron. Tetrahedron means it have 4 triangular faces. 1, 2, 3, 4. 4 triangular faces. Each face having 4 equivalent quadrilateral faces and 4 vertices. This one is called as tetrahedron. Next, coming to method of analysis. Method of analysis means doing problem, solving problem by using analysis. Method of analysis is again classified into 2 types. One is analytical method and second one is the numerical method. Coming to analytical method, they are again classified into 2 types. One is exact method and second one is the approximate method. Exact method means we are using some conditions. Based on those conditions, we are doing some problems. Second one is the approximate method. Approximate means here we are using Rayleigh-Ridge method, Galerkin method, some methods. Every method has some equation. Rayleigh-Ridge method has some equation, Galerkin method has some equation, weighted residual method has some equations. Based on those methods and equations, we are doing and solving this problem. Next, coming to numerical method. Numerical compared to analytical method, numerical method is based on some mathematical formulations. That means differentiation and integration. Numerical method is again classified into numerical solutions of differential solutions and FEM. FEM means finite element method. Next, NDE again classified into numerical integration and finite difference method. See the difference between FEM and FDM. FEM is finite element method. FDM means finite difference method. Difference I will tell you later. This is the analysis methods used to solve the problems. Next, coming to advantages and disadvantages. That means merits and demerits of FEM. Coming to advantages, modeling of irregular bodies. Irregular means not an equivalent shape. That means equivalent dimensions. That irregular shaped bodies are very easy to model by using FEM. Next one, it can handle general load condition. Load condition means we are applying some weight on beams, frames, etc. For example, taking simply supported beam, we are applying load in middle, that means center. That means general load condition, W, weight. It can handle general load conditions. It can handle more number of boundary conditions. Boundary conditions means Again, I am taking example simply supported beam. Simply supported beam having two fixed ends. In two fixed ends, we are fixing. Fixing means they are not movable. Fixed means they are called as boundary conditions, boundary elements. Those two are fixed. So I am fixing Q1, Q3 is zeros. Those are boundary conditions. It is very clear in above and become problems. Coming problems I will discuss. Next, for compared with analytical, FEM model is where FEM modeling is very easy and cheap, easily available. Next, it can handle non-linear behavior. Non-linear, linear means straight form. Non-linear means curvature. Why I am telling that curvature means here I am applying load. That means in simply supported beam, I am applying load in center. So the deformation can be in center only. That means in non-linear behavior. So by using FEM, we can handle non-linear behavior also. Those are the advantages of FEM. Next, coming to disadvantages, demerits of FEM. FEM is a time-consuming process. Why I am telling that? I am stating that statement because that FEM is a time-consuming means this is a analytical method from first process initial to final. First process I am taking every individual stiffness matrices for elements, finding K1, K2, K3 and so on. Next, assemblage of stiffness matrix and finding global stiffness matrix K equal to K1 plus K2, K3, K4 and so on. Next, finding nodal displacements, load vectors and finding resultant forces, stress strain relations, stress strain calculations, computations of forces. This is all time taking process. So I'm stating that method is a time consuming process. Second one, in order to analyze many number of small elements due to human fatigue, we have to depend computer package. This is also right. For calculating all elements stiffness matrices, we are depend on some package. That means some computer softwares. This is also demerits of FEM. Next, the result obtained using FEM will be close to exact solution. That is not exact solution. This is approximate. By using FEM, we can get approximate solutions, not to exact solution. This is also a demerits of FEM. Exact. These also exact results cannot be produced of analytical method. Next, fifth one is the important. If we don't have proper knowledge about especially matrix, algebraic differential, problem solving is very difficult. Main demerits are time consuming process, knowledge about matrix, algebraic differential, problem solving is very difficult. Results are not exact. Those are appropriate results, approximate results. These are the advantages and disadvantages of FEM. Okay, any doubts? Please respond. Any doubts?
No, sir.
If you have any
Do you
doubts,
have any
please
doubts?
ask.
Please ask. Okay, sir.
Okay? Okay.
Okay, sir.
Next, coming to engineering applications of FEM. Next, engineering applications of FEM. I am discussing engineering applications of FEM based on area of study and analyzing the problem. First of all, I am taking civil engineering, your branch. Civil engineering structures. In civil engineering, we are discussing and analyzing of trusses, frames, and pressure pre-stresses concrete structure. That means truss. Truss is a structural member. In this, it will have only two forced members, but all members are gathered and act as a single member or single object. Truss. Pure example for truss is a bridges. Next, frame. frame is a straight bar. In this, frame is a straight bar. In this, the deformation, it will not only in axial direction. It can be obtained in obtained in perpendicular direction to the axis of beam. It will be called as a frame. These are the definitions for truss and frame. Next, civil engineering, we are analyzing trusses, frames, folded plates. Coming to aircraft structures, we are analyzing aircraft means rockets, missile structures. Okay, in aircraft industries, we are analyzing rockets, spacecrafts, missile structures using finite element method or finite element analysis. Next, heat conduction. Coming to third one, heat conduction. Temperature distribution in solids and fluids. It is completely related to the heat distribution. Heat distribution from solid to liquid. Solid to solid, it one is called as conduction. Solid to liquid, convection. Solid, next, space, radiation. Next, mechanical design. Coming to mechanical design, we analyze pressure vessels, gears, linkages, etc. Electrical mechanics and electromagnetics. We analyze synchronous and induction machines. Eddy current losses in this electrical mechanics. Coming to hydraulic and water resource engineering, we are analyzing potential and free surface flows. Okay. Laminar or turbulent. Laminar means complete flow, single flow. Turbulent means zigzag flow. Remember that. Next, coming to geomechanics. Geo means earth. Geomechanics means in this we are analyzing excavation, retaining walls, underground openings, rock joints, soil structures, dams, etc. In nuclear engineering, analysis of nuclear pressure vessels, temperature distribution in reactor components. Coming to final, biomedical engineering, analysis of eyeballs, bones, teeth, etc. Those are the total complete 9 or 10 applications based on area of study and analysis of problem. These are very important in external point of view. So please remember that. If possible, I will provide that material to you. Next. మా డౌట్ ఏమైనా ఉందా?
No, sir.
మా డౌట్ ఉంటే అడగండి, ప్రాబ్లం లేదు. అర్థమవుతుందా మీకేమన్నా?
అర్థమవుతుంది సార్.
డౌట్స్ ఏమైనా ఉంటే అడగండి, అడగవచ్చు, ప్రాబ్లం లేదు.
ఓకే సార్.
ఓకే కదా?
ఓకే సార్.
వెరీ వెరీ ఇంపార్టెంట్ అమ్మా, ఎక్స్టర్నల్ పాయింట్ ఆఫ్ వ్యూలో ఇవి అడ్వాంటేజెస్ అండ్ డిసడ్వాంటేజెస్ ఆఫ్ ఫెమ్. నెక్స్ట్, అప్లికేషన్స్. చెప్పినవన్నీ కూడా ఎక్స్టర్నల్ పాయింట్ ఆఫ్ వ్యూలో వస్తాయి మాక్సిమం. ఓకేనా? ఈ మెటీరియల్ కూడా మీకు గ్రూప్ లో సెండ్ చేస్తాను నేను. నెక్స్ట్, మైక్ ఆఫ్ చేసుకున్నాను. నెక్స్ట్, వెరీ ఇంపార్టెంట్ టాపిక్ ఇన్ ఫెమ్. Please switch off your mics. Next, coming to important topic, steps involved in solving of problem using finite element method. This is very important topic in external point of view. In FEM, it follows an orderly sequence of step-by-step procedure. I am telling that all steps are very important to solve any problem. It will be in bars, trusses, frames, axisymmetric elements, isoparametric elements, 4-noded, 8-noded, CST, etc. For solving any problem, we required these complete steps to solve any problem and finding the solution. Okay, I'm reading all steps completely. Step 1. discretization of structure. Second one, selection of proper interpolation and displacement model. Third one, derivation of stiffness matrix. Fourth one, assemblage of element equations. Next, selection of unknown nodal displacement. Computation of element stresses and strains. Coming to first one, discretization of structure. Discretization means dividing. For example, I'm taking one structure or one bar. I'm dividing one bar into three elements. That means initial point, middle point, third point. Those are the elements, nodes. So in this procedure, I'm telling that discretization will be dividing the structure into nodes or elements. Elements are two. I'm taking example, simply supported beam. In simply supported beam, two elements and three node points. First one, second one is first one, last one. Those are elements, and middle point, first and last are nodes. Okay, remember that. By following this procedure, discretization will be done. Discretization is nothing but dividing the structure into subdivisions according to basing on the type of element, size of element, location of nodes, number of elements. Type of element means I'm taking simply supported beam. That element will be two elements. I'm taking next bar or frame, truss. Elements will be changed according to type and size of elements. Next, location of nodes. Location means when in middle point or end point there is any weight is applying, so the element is changed. Next, second point, selection of proper interpolation or displacement model. In this point, I was previously told you, selection of proper interpolation means applying boundary conditions. We are already discussed about that. Boundary conditions means fixing positions. In any bar or any frame, any truss, any stationary fixed rigid position will be boundary condition. That means selection of proper interpolation or displacement model. That will be Q, denoted by Q. Selection of proper interpolation. Third one, stiffness matrix. Derivation of element stiffness matrix. That will be finding of individual stiffness matrices. That means finding each stiffness matrix. That means K1, K2, K3. K is denoted by stiffness matrix. That means K equal to AE by L. Area, Young's modulus, next length. AE by L, K1, K2, K3 and so on. This will be the element stiffness matrix. Next, coming to fourth step, assemblage of element stiffness matrix. Assemblage means KQ equal to F. That means assemblage of means K equal to K1 plus K2 plus K3 and so on. This is the assemblage of element stiffness matrix. After that, we are finding assemblage of element equation. KQ equal to F. Here, K means stiffness matrix. Here, let's see, where K equal to K1, K2, K3 and Kn and so on. Here K equal to stiffness matrix, Q equal to nodal displacement, F equal to force vector or load vector. And fifth one, solution of unknown nodal displacement. Unknown nodal displacement means finding of Q. F is already known factor, but finding of Q by depending on various factors like temperature gradient, like stresses, strains, load vectors. Loads may be point loads, body loads, okay, having different load vectors. Based on those load vectors and temperature gradients, Q will be find out. This is the fifth step, solution of unknown nodal displacement. Next, coming to sixth step, this is the final step, computation of element strains and stresses. This is the final step. Some problems may be find out resultant forces. Those are the final steps. But initially, those 6 steps. Finding initial to final step. Computation of element stresses and strains. Here, I am previously told that K will be the element stiffness matrix. KE element stiffness matrix. K equal to global stiffness matrix. Global means K equal to K1 plus K2 plus K3. QE is the nodal displacement. Q is the global nodal displacement. Global nodal displacement vector is used for finding stresses and strains. Fe is the element load vector. F is the global load vector. F is used for finding force load vectors. So finally, KQ equal to F is the final equation. Finally, you are find the element stiffness matrices. After that, finding K equal to K1 plus K2 plus K3. After that, assemblage of element equations. KQ equal to F. Q will be the nodal displacement. F will be the load vector. This is the final equation. After that, we will find the stress and strains equations. These are the main steps involved in solving any problem related to bars, next beams, frames, trusses, etc. I'm taking only simply supported beam, whereas in cantilever beam, one end is fixed, another one end is free. Okay. Any doubts? Please respond.
No, sir. No, sir.
Ma total strength enthamma?
11, sir.
11. Okay. Please stay there. Don't go anywhere. I'm taking attendance.
Okay, sir.